As we move into the 19th century and start to take a look at the role of science and society in human history, perhaps one of the most controversial yet most important works of the 19th century must lie in Charles Darwin's The Origin of the Species, 1859. It's the aim of this video on this most controversial issue to discuss the historical context of Charles Darwin, to think about the influences around him. How did he come to this theory? How did he come to this most interesting and provocative work? Let's start with background. As we said before in the previous content folder, the 19th century was a watershed for biological research, for biological findings. We have Gregor Mendel in 1856 talking about doing experiments with peas in Austria to demonstrate issues of heredity in what will become the field of genetics. We have Rudolf Virchow in the same year postulating that cells are the basis of life. 1857, Louis Pasteur in France, fermentation produced by microscopic organisms. All this within a few years, and then in 1859 we get Darwin. Let's think about some of the assumptions about the world, about various species, biological species prior to Darwin. We have this understanding that species of animals and plants were created separately and remain fixed, like producing like. This is from McClellan and Dorn, page 323. That prior to Darwin and his theory, we have this understanding that God created the earth, animals were created at a fixed time, the earth was created at a fixed time, the earth, the animals, the planets, humans, created it all together in one major event, right? And that the species, the animals, the plants, remain fixed. Like species producing like species. That's very difficult to say, sorry. So cats produce cats. Blueberries produce blueberries. Blueberry plants produce other blueberry plants, yeah? Creation dated to approximately 4,000 BC, somewhere in that time period. Many people had attempted to take time backwards to try to figure out how old humanity was, how old man's relationship to God was. And so the 4000s BC were an attempt to take us back to the history of creation, to the Hebrews, if you will. So human history, the history of the planet, the history of animals and plants is rather young, and also rather recent, and static. It doesn't change. So all the plants and animals that ever were all created at the same time and continue to be. That was the worldview previous to Darwin. Darwin's ideas, when they come along, are like those of Copernicus. They were revolutionary. So once we get his theory there, we have this understanding of no separate creation. Biological and geological change have been unfolding gradually over eons of time. So there's no one, boom, separate creation, right? It's sort of a continuum. Biological and geological change have been going on and unfolding gradually over eons of time. Humankind is an artifact of the history of nature. Humankind is actually an artifact of the history of nature. The study of nature offers no evidence of any divine plan. So these are literally earth-shattering, revolutionary concepts once Darwin's theory gets out there and begins to be discussed, right? There is no static, set, one-time creation. Instead, biological and geological change have been unfolding over long periods of time. Humankind is an artifact, of the history of nature. So humankind is part of nature, part of the history of nature, and the study of nature offers no evidence of any divine plan. Again, you can find this in McClellan and Dorn, pages 324. More to say about the background to Darwin. With the scientific revolution, there developed also in his day, in his time, previous to him, this idea of a natural theology. Inspired again by the scientific revolution to investigate the apparent design in nature, we could better understand the great designer, i.e. God. So the scientific revolution actually inspired something like scientific investigation into the design of nature, that there was actually a design, an intended design to nature, and we can better understand God by trying to understand that design. Some of the images I have here for you surely might inspire us to consider this, yes? When you see this beautiful cascade of color, the trees along the river, this follows a season, right? This is fall. This follows a season. This follows a pattern that seems to be somehow divinely inspired. When you look at this walkway here that looks like a tunnel, right? A tunnel through the forest. It's beautiful, naturally created. Natural theology culminates in a group of writing, a group of connections, conferences called the Bridgewater Treatises. This collection of studies aim to demonstrate, quote, the power, the wisdom, and goodness of God in the works of creation. Again, when you think about that idea, right, that there's a plan, there's an order, the power, the wisdom, and goodness of God in the works of creation. So when you take this natural theology, if you will, and combine it with other kinds of inquiries going on at the time, we have other precursors to Darwin who are trying to figure out what are the rules behind things that they see. And I have a few suggestions here to consider. For example, in France, we have the superintendent of the Royal Gardens in Paris. And if you've ever been to Paris, and I encourage you to go, you know that the French love their gardens. And this has been going on for quite some time. And this Count de Buffon in the 18th century noticed in all of the work he was doing tending to royal gardens, developing them, giving them extraordinary care, that plants evolve. They change. And he noticed this change. And it was change that he could understand, and he even documented it. And this was based on empiricism, based on observation. Other precursors, and we have the naturalist Jean-Baptiste Lamarck, also late 18th, moving into the 19th century. He will postulate that that there is an inheritance of acquired characteristics. He says, by uses and disuse of parts, an individual organism modifies itself to adapt to its environment. He could not prove all of his theories empirically, but he put these theories out there, in particular giraffes. Again, he can't prove this, and no one, I believe, can, but he argued that giraffes once did not have long necks, and that the reason that they have long necks is that because over time they were trying to eat the leaves that were higher and higher in the trees, and so therefore they had to develop longer and longer necks. Now, we have nothing to support this, but these are some of the kinds of writings that are going on, some of the kinds of ideas that are out there. Other precursors to Darwin, in the 19th century, we're starting to discover more fossils. Lots of discoveries of fossils, and discoveries of large vertebrate fossils of creatures no longer living on the earth. No longer living on the earth. People called some of these elephant bones, I think they called them. They were dinosaur bones, is what they're finding, but they considered them to be bones of elephants that perhaps once walked the earth or once walked in the region, but essentially they were finding, as they began to study things, they began to find that these creatures no longer lived on the earth. So why on earth are these bones here? Well, biological extinction must be a reality, that this animal once lived and now no longer does. Right? So we're finding evidence of fossils of things that no longer exist. This means that extinction happens. Other things to consider: geology. We get Charles Lyell, very famous philosopher and scientist, who begins the work of trying to understand the Earth. He suggests, or he argues, physical features of the Earth are a result of long and continuous processes. Some of these processes are still happening today. So, earthquakes, volcanoes, these are processes that continue to change the face of the Earth, continue to shape the Earth. And these have been going on for a very long time. So the first studies of geology starting to postulate how old the Earth might be. Charles Darwin himself is born right in the middle of all this time period, right in here in the 19th century, the 1800s, just after Shelley has published Frankenstein. It's just out there, right? His father is a physician, his father's a doctor. His maternal uncle is Josiah Wedgwood, and when we were talking about the industrial age, know that that means he's in a family of sort of upper middle class family, educated family, but also a family of entrepreneurs. So Wedgwood, one of these industrialists who's been trying and failing and trying and failing. So a very interesting family to be part of. In his early life, he attended the University of Edinburgh and was attempting to study medicine, but that following in the footsteps of his father. We understand his father was rather controlling. Again, I don't know how far we can take sort of psychology of Darwin, but father very demanding, wanted him to go into medicine, following his footsteps. Darwin decided that medicine was not for him, and he transferred to Cambridge to study theology. While at Cambridge, he studied with geologists, he studied with botanists, in addition to studying with theologians. So he had a very broad education while at Cambridge. He was a member of Christ's College, and that is one of the colleges that makes up the university that is Cambridge. Still there today. While studying, an opportunity came up. He had just finished his degree, as I understand it, and he was either going to go into a nice, quiet life as a preacher, as a leader of a parish, or he could do a 2-year voyage on the HMS Beagle. And this, well, it started off, it was supposed to be a 2-year voyage. It took much longer. And he went ahead and he signed on for this. It turned into a 5-year voyage. It's a mapping project of South America. And he took along some books to read. In particular, he took along with him Lyell's Principles of Geology. This map is to show you the route of the HMS Beagle. And as you can see, it comes from Plymouth in England. Right, so I can get my map. There you go. Starting off in England, coming down to South America. Right, going all around South America. Here are the Galapagos, the very famous islands he explored, all the way around. So circumnavigated the entirety of the globe. So quite an adventure, quite an ordeal. This inset here gives you a little bit better understanding of the Galapagos Islands here off the coast of Ecuador. They're part of Ecuador today, and you can see there's quite a significant number of islands there. So along the way, they stopped off first off the mainland of West Africa. They stopped at the Cape Verde Islands. And Darwin noticed that there were animals on the Cape Verde Islands that were similar to, but not exactly the same, as those on the mainland of West Africa. So he made note of that, again, using empirical evidence, taking lots of notes. He then, when they went over to the Galapagos Islands on the other side of South America, he noticed the same thing. The animals on the island were similar to the animals on mainland Ecuador, but also strikingly different. We have some images here. I can only imagine what it was like to come to this amazing location, so very different from England, those of you who know England, and to see these amazing sights, these amazing animals here in the Galapagos Islands. Now, of course, these images are all modern. This must have seemed just very much otherworldly. People talk about the Galapagos as a lost world, that human intervention had not succeeded in changing what was going on here naturally. And we've tried, in the modern sense, to keep it untouched. Except, of course, for small children who are part of a tourist family coming out to take a look. These are probably my favorite, the two blue-footed boobies, just having a conversation probably after their morning tea. So really extraordinary wildlife on this island. And of course, as you know, as your McClellan and Dorn will tell you, it was these observations here that got him to start thinking about why species appeared to be different, particularly with finches. He was working on birds, looking at finches. Why would a finch seem to change just because it's on this island, right? Why was it changing? And he noticed in particular the beaks of finches changing depending upon the kind of food that was available to them, right? So another influence on Darwin, other than his travels, other than his family upbringing, his college, his theological background, his medical background. Another influence of the day was Thomas Malthus, and Thomas Malthus wrote an essay on the principle of population. You should know that Malthus is what we will call a social scientist. He was working on the problem of poverty and working on the problem of famine and trying to understand why it is that what's the best course to take to try to deal with that. He noticed, or he made the observation, that populations increase geometrically. In other words, two people may have two children. Those two children will then each have at least two children, say, if not more than that, and so forth and so on. So one couple, if you will reproduce themselves through their generations geometrically. There'll be more and more. The food supply, he suggested, on the other hand, only increases arithmetically. So his conclusion was that a population will, of necessity, have to outpace its food supply. He'd seen this with animals with their within a different area, and he applied the same thing to people. He said, when a population outpaces its food supply, fierce competition will ensue in which the swifter, stronger, more cunning are likely to survive and reproduce. Thomas Malthus very famously, when put to work by the British government on what to do about the Irish potato famine, suggested that there were many ways to go. And he said, yes, of course we can send food over to Ireland and try to feed people, but honestly, poverty, famine, warfare are just part of the natural processes, he said, the natural laws associated with population that allows for people, particularly poor people, to die. And you could feed the poor, he suggested, but they'll only reproduce geometrically, and then you'll have to provide even more food. It's heartless, and Malthus is not considered correct in many of his assumptions, but he argued to the government that it would be better to allow the Irish to starve. His advice was followed to an extent. So social science, not its finest hour, but this is some of the sort of information that's out there. And in particular, we're focusing on this idea that when a population outpaces its food supply, fierce competition will ensue, in which the swifter, stronger, more cunning are likely to survive and reproduce. Again, perhaps one of those influences on Darwin. So to recap, Darwin's influences as he is investigating the Galapagos, making his observations on the Galapagos, it's a time of fossils being discovered where we find that some species no longer exist. It's a time of geology, and we're developing understandings of geology. Great works on geography. He's on a ship in order to map the Earth, map certain continents and regions. It's a time of natural history, but also a time of trying to look at theological science as well, trying to look at nature through the eyes of theology, but also the eyes of science. We have social science, such as Malthus gives us. His travel on the HMS Beagle, again, his close observations, empirical evidence gathering. All of these coming together. So what does he conclude when he comes after looking at the Galapagos Islands and doing more and more research on different kinds of animals, different kinds of species? He says, despite high rates of reproduction, population species are kept in check by high mortality as individuals compete for resources, and those best adapted to the habitat are more likely to survive and produce offspring. The pattern, if given enough time, could account for patterns of variation in the species he had observed on his voyage. Again, this is coming from Colin Dorn. So he is looking primarily at animals, birds. So again, those best adapted to the habitat are more likely to survive and reproduce offspring. The pattern, if given enough time, could account for patterns of variation in the species that Darwin observed on his voyage. So why not publish as soon as he pulled all this together? He waited, and he waited a long time. This image you have here is one of the pathways near the house he has where he's doing he lives and works after his long voyage. He waited. Why did he wait? There were some issues about health, perhaps. Perhaps his health prevented him from just doing all this work. He was worried about criticism. Yeah, criticism from the scientific world, criticism from other regions, other elements. He wanted to develop his science chops, I'm suggesting, in the community with smaller studies. He starts off as a medical student, then he becomes a theologian. But keep in mind, he's one of these gentleman scholars. He's a hobbyist. He collects bugs, he collects beetles, and he's looking for different interesting elements to different beetles, right? And one of he has an extraordinary collection of these, and you can go to museums in England and find these collections. It's just amazing how many beetles he had. So he wants to develop his science chops, and he will publish some 40 other works before he delves into the origin of the species, because he wants to get his science credentials in order. He gets scooped, though. He waits too long. One of his colleagues, one of his friends, a gentleman he worked with quite a bit, Russell Wallace, was himself on a voyage. And now this is off the coast of Asia. Here is the Malay archipelago, sorry. And he too is self-taught. He too traveled broadly. And when he begins to take a look at the various species of animals and birds that he finds here in Malaysia, he starts to say, natural selection is the driving force of changes in species. And he writes a letter to Darwin in 1858 and says, hey, I have an idea. I think I'm going to publish this. And Darwin's like, I've already got this. So Darwin rushes to publication for 1859.